Hi, welcome to the University of Alberta Permaculture Group presentation. We will be talking about greenhouse gases and aquaponics along with some fun at-home experiments and activities. There will be a quiz to test your knowledge with a randomly chosen winner who scored 100% from Alberta that will receive a prize. You can only try the quiz once, so make it count. Also, for the questions that we ask throughout the presentation, there will be a document below for you to check out the right answers. So, a little bit about our group. Our goal is to build carbon neutral systems which function to provide food. Carbon neutral means that the net carbon released is equal to the amount we input. It does not change the amount of carbon dioxide in the air. The way we're achieving this is building an aquaponics system and are proud to build it this summer after all the work we've put in. Aquaponics has the potential to use 90% less water when growing crops, and this is a substantial amount since water is a huge part of modern day agriculture. Additionally, we have other projects such as our algae canopy, which will function to remove CO2 from the air, providing shade for aquatic life, or in urban environments as architectural features with positive environmental impacts. So let's talk about the greenhouse effect. The greenhouse effect is basically sunlight is absorbed by the earth and some is reflected as infrared rays. The rays are trapped by greenhouse gases, which can absorb these infrared waves and radiate them or reflect them back towards the surface. More greenhouse gas in the atmosphere causes an increased retention of heat, which causes global warming, increasing the temperature of the Earth's surface beyond normal levels. Greenhouse gases include, but are not limited to, carbon dioxide, water vapor, and methane. We can actually test this with a simple experiment. In an experiment, you want to keep everything the same except for one thing. That is how we know that the thing we changed actually caused the effect we saw. In our experiment, you're going to need a few things. 2 similar clear containers, anything that's around the same size. An elastic, 2 ice cubes roughly of equal size, some cling wrap, damp soil, and a sunny windowsill or a bright light bulb. So how we're going to set up this experiment to prove the greenhouse gas effect is to place an equal amount of damp soil in both containers. Then place an ice cube on top of them at the same time preferably, and then cover one of the containers with cling wrap and secure it with an elastic. Then put both containers in a sunny window or the same distance from a bright light bulb. Let's start with some questions. So, which ice cube melted faster? Or which one do you think will melt faster? Would it be the one with the cling wrap on top or the one open to the air? Also, what do you think about the cling wrap affecting the melting time? Does it make it shorter, faster, or make it stay the same? So basically how this experiment works is the cling wrap acts like the greenhouse gases by absorbing some of the heat and radiating it back as well as reflecting some of the infrared rays back. It's also clear like the air, so the ice cubes receive the same amount of light. So by doing this, it increases the relative temperature in that space between the ice cube and the cling wrap. This will in effect make the ice cube melt faster. So let's head on to aquaponics. Aquaponics is a system that combines aquaculture, which is raising of fish or other aquatic organisms, something like a salmon farm, with hydroponics, which is growing plants in water. And this is done in a symbiotic environment. In the diagram on the right, you can see that there's a relationship between the bacteria and the plants and the fish with the bacteria. How does this work? Well, looking at the aquaponics system on the bottom left, you can see here that if we start with the fish who are fed fish food and are growing, they produce waste. And this waste is pumped through a biofilter. This biofilter has bacteria in it. So the bacteria take that debris and fix the ammonia, the nitrogen in the ammonia, into nitrates. Now, nitrates are a very important part of plant fertilizer. So what we do is we take those nitrates and pump it into the tanks holding the plants on the top there. These plants use the fertilizer nitrate and grow, thereby taking out the nitrate that are bad for the bacteria as well as bad for the fish. And then this recycled water is given back to the fish clean. Now, basically, this is what a symbiotic relationship is. A symbiotic relationship is any relationship between organisms. There are three forms: mutualism, parasitism, and commensalism. Our system is a complex mutualistic relationship where the toxic excretions of the fish are removed by the bacteria, which use the ammonia and create nitrate as waste. These nitrates are then used by the plants to grow and then remove them from the system. All three organisms benefit. The plants get nutrients, nitrogen is the fertilizer, the bacteria fuel their metabolism, and the fish get clean water. The earth has finite resources which we need to use responsibly to care for ourselves and the earth by limiting resource consumption to a sustainable level. And this is how we increase that efficiency to allow more people to get more food. It harbors a lot of potential, especially in combating food scarcity. There are other benefits as well. If everyone can have this in their home, it means that we do not have to transport as much food to remote areas, and as well as people in remote areas can have food year-round should they have stuff like this. We can also use this technology to use real estate for farming that wouldn't naturally be used, such as rooftops or city skylines. So now we have a do-it-yourself hydroponic system for you. And it's not the same as aquaponics system because it does not have fish, but it is an easy at-home proof of concept of growing plants in water. Surprisingly, the plants will receive enough nutrients and will grow just fine. And there's a ton of plants that you can grow, and you only need a few things. So the most important one is a plant, preferably a young one with its roots still intact, because the roots are the plant's lifeline, and you want to be especially careful about that. A pop or a soda bottle, just used as a container and a plant holder, feel free to innovate or use what you have. It's just meant to repurpose something that you have, and as well as some water. What you're going to do is carefully remove a small plant from the soil, making sure to keep the roots intact. You can do this by making the soil wet or by just very carefully wiggling the plant out. If you pull the plant out without its roots, you will have to use another one. Next, you want to have an adult carefully cut a plastic bottle in half, similar to the one on the right of the screen there. Be especially careful, sometimes it can be a little sharp. Take the base side of that water bottle and fill it halfway with water. We will be flipping the other side with the mouthpiece into the water. You don't want to fill it all the way up. Halfway should be fine. Then you want to gently, very gently, pull the plant roots through the opening of the top half of the bottle. This will allow you to stabilize the plant as well as put it into the water in the next step. So when you're putting the roots in the water, you don't want the full root to be fully submerged. That way there can still be some gas exchange for the plant roots to breathe. Next, you want to place it in some sunlight, and if the water level drops, just add some more water to get the roots submerged again, but once again, be careful about overfilling. Now, there are tons of plants to use, and here are some cool ones. You can do some African violets, some fiddle leaf fig, some spider plant. There are so many, and we've even got more slides of them. And all you have to do is either take a cutting or anything like that, but the most important thing is if it's a small plant, you want to have it with the roots. So here are some more plants that you can actually eat. We've got basil, chives, oregano, mint, rosemary, and sage. There are a lot more. Feel free to Google them. We thought these were some awesome ones that you can actually use right away, so feel free to try them out. This is a rendition of kind of what it would look like. You want the roots to be partially submerged in the water and the plant to be above the top of it, so then it gets enough sunlight and isn't hindered by anything dark or not transparent. As you can see, the thing with the water bottle is that it is transparent, so even though some of the light is blocked, the leaves will still get enough sunlight anyway. And you can feel free to mess around with this and send us your creations. Thank you for learning with us. We love doing things like this. Feel free to send us your results or tag us on social media, plus our email permagerp@ualberta.ca. Ask us any questions and any ideas you may have, as well as send us your video of your hydroponic system or what you thought of the greenhouse gas experiment. Once again, thank you for learning with us, and feel free to do that quiz. It's a quick prize and a great learning opportunity, as well as check out the document below for the answers to the questions of today's lesson. Thank you.
Thank you so much for watching Future Energy Systems video. Make sure to subscribe so you don't miss any of our exciting content. Check out the links below to our website and learning page where you can find activities, learning extension, and more. You can also sign up on the website for notifications for future videos and interactive opportunities. There's so much to learn as we explore our energy future.